So we're going to solve the following definite integral, and based on the structure of this product, we're going to need to use integration by parts. So we get to pick a u, and we'll get to pick a dv, and then we'll calculate the v and the du. Now when we have this, when we have a power function times a trig function, most of the time our u is going to be x, and our dv will be what's left over, which is cosine of x dx. This makes our du simply dx, and our v becomes sine of x, the antiderivative of cosine x. So we can start to put together our structure, which is u times v, so x sine x minus the integral of v du, so sine x dx. Now we do still have a definite integral. I'm going to save the limits for the end, but we can put them in here just to make sure we don't forget about them. 0 to pi over 4. So finally, x sine of x minus the antiderivative of sine x is negative cosine of x, and then from 0 to pi over 4. So let's take care of this first, and then we'll incorporate our limits. X times sine of x plus cosine of x from 0 to pi over 4. And now we can input our limits. So pi over 4 times sine of pi over 4 plus cosine of pi over 4. So that's our upper limit, minus 0 times sine of 0 plus cosine of 0. Now, it's a good thing that we actually went through the steps of plugging these in, because remember, cosine of 0 is 1. It's not 0, so this second part did not zero out. So this first part, we have pi over 4 times rad 2 over 2 plus rad 2 over 2 minus, now this all becomes 0. This guy here is equal to 1. So a few different ways we could write the final answer, but let's just write out the terms here. So pi times square root of 2 over 8 plus rad 2 over 2 minus 1 is our exact answer.